Just getting the YouTube stream started up quick. All right. Good. Okay. Critical thinking. Hi. Jed. Oh yeah, you broke Spectre's streak, and you got your watch streak started up again. And Yanis, hello to you too. Still stuck in limbo. I put limbo past me after, having a bit of rage yesterday in a good-natured way. Also, I prefer the beginning part of limbo where they're just like constantly trying to like trick you. Towards the end, those puzzles got me really annoyed. I did win, yeah. Just at what cost, though? Critical, do you have any questions? And so feel free to let them rip. Otherwise, I'm just gonna take a quick look around on the internet and probably go over to abstract algebra. Even then, it's not. We're not even getting to real abstract algebra yet. It's more like doing the preliminaries with number theory, which I'm kind of surprised that you need number theory for abstract algebra. That's not what my impression of it was. From your analysis exam yesterday? Sure, Yanis. Real or imaginary? Is there imaginary number theory? I do have the book open right now. So like it's going through chapter 0. So like these two are solidly like number theory-ish, from my impression of them. I guess induction is also to me. There is complex numbers, but I'm also kind of surprised. Gauss numbers is imaginary number theory? Oh, okay, Bode. And then implementations I've heard of, I don't know what they actually are. And then I know what a function is, but they're going to talk about functions in a different sense that I'm used to. But I have not gotten far in this book at all. I tried going through a little bit on Thursday, but we got kind of bogged down with questions from chat. So I only got to look at like one or two of the proofs, which is good. It's the point of the stream is to answer questions from chat. Okay, so, well, you thought it was fun anyway. It's one of those problems that's clearly true. It can sometimes be hard to prove. Let f that maps 0, 1 to r be continuously differentiable with f of 0 equals 0, f of 1 equals 1, f prime of 0 equals negative 1. Whoa. How are you differentiable at an endpoint? I'm already confused. Like f prime 0 shouldn't be, even if it's inclusive, I don't see how that's defined. I guess you can manually say it's negative 1. Okay. I guess I can buy that if it's like a piecewise defined derivative. You continuously differentiable with f of 0 equals 0, f of 1 equals 1. Oh. This is like some, it's almost like some kind of different version of, what would it be, like a mean value theorem or intermediate value theorem type of thing. So if you start at 0 and you're decreasing immediately, it means you have to dip into the negatives. And then if you end at a positive point, you have to hit, you have to go through 0 at some point because it's continuous. So we definitely need intermediate value theorem in here, but that's kind of the easy part of the proof. I assume the hard part is proving that f does indeed become negative. and kind of like finding an exact point where f is negative and naming that point so you can apply the intermediate value theorem. Let's try it. You have my interest here. Talking about f prime. Oh, shoot. Okay, no, you just blew the lid off everything that I was just saying. F prime has a 0. Never mind. Okay, what is happening here then? Yeah, the prime right there, I don't know. I don't have an idea of what you do immediately. Okay. So, oh wait, maybe I do have an idea what you, okay. So let's make a sketch of the basic scenario of what f is, but there's more scenarios that f like could be that we're just not going to worry about right now. Just get our basics down. So we're given 2 points for f, and 0, 0, and 1, 1. We're given that f prime of 0 is -1, so we must start going down and then we come up. Something like this. But there's a lot more possibilities than just that, because you can start coming down, come up, come down, up, down, like stuff like that we're just not going to consider yet. Okay. And so just visually, we can see that, you know, the tangents here are negative and the tangents there are positive. So maybe we can make another intermediate value theorem argument. We basically want to show that f of x is decreasing here and increasing there for whatever that point may be. But we can't presume off the bat that, like, the entire point is to prove that this is a valley here. So we can't just, like, presume that the valley exists because we haven't proved it. Okay. I mean, but I feel like I nearly kind of said the argument is just... trying to kind of piece things together and build the bridge between the points that I'm making, I guess. Clearly true, but hard to prove. Yeah, exactly, Jed. So maybe the part that, so when I was initially talking about the problem, I thought that was just f and not f prime, I was saying that maybe it'd be hard to prove that f is negative here and positive there, but maybe it's actually not that hard to prove it. So, man, this is really not very formal. So maybe make an argument for this like basic form of the function and then try and generalize it a bit, because I think to generalize it, we're going to have to do some funky stuff. Notice that f prime of 0 equals -1 implies that f prime of 0 equals -1, and f of x being continuously differentiable. Actually, maybe it was not that hard. Let's see. Imply that f prime x is negative over some interval 0. I guess we can say x sub 0 for some x sub 0 belongs to 0, 1. Well, surely not the last one. I mean, it doesn't hurt to include it, but we can make a bit stronger of a statement there, right? Okay. And so now we need to somehow get to the stage where our function must increase after a certain point. How do I say that, though? Like, could this be a mean value theorem thing? Because the average slope between here and here is, it must be mean value theorem, right? Because that's how we can name a positive slope that definitely happens. Dude, I can't write. What am I writing? F prime of x is equal to 1, or f prime of x1 is equal to 1 for some x1. So all the mean value theorem will give us is that x1 is between 0 and 1, like that, I think. The endpoints I'm not particularly concerned about, I guess, but now I want to make some kind of statement that x1 must be between x0 and 1, right? Since f prime of x is less than 0 for 0 to x0, oops. Well, yeah, we don't have to include that. Actually, you should be open. Because I'm going to say that x0 is my 0 point for the derivative, right? Okay. Then it must be that x1 is actually in x0, 1, right? And so have we set up our intermediate value theorem right here? I guess we could be even more. Take any x2 from 0 to x0 and observe f of x2 is less than 0. Now we say by intermediate value theorem by intermediate value theorem, f prime of x is equal to 0, between, what am I saying? X1 and X2? Yeah. And I mean, you can maybe go a step further and say that happens at x0, but maybe that's not really necessary for the sake of the question. Actually, I could say this better though, right? F prime of, well, I should say C, I guess. I'm being really messy with having so many constants. I'm sure you could express the same idea with fewer constants involved. For some C belongs to, is it intermediate value theorem? Does that include the endpoints? It probably does. I'm saying x1 and x2. Actually, x2 is before x1. That's kind of weird. This proof is pretty messy, but I think I have the idea. You show the derivative is negative on some interval, positive on another, and at some point between that, it must be 0. Checking in on chat. Yeah, it's f prime x less than 0 for x and x0 is not true. Wait, really? Yeah, critical. I can take a look at that problem after this. You have f prime. Okay, let's see. Also, hey, Gold. As long as it's continuous. Yeah, that's what I was thinking. The continuity saves that statement. F prime x is less than 0. Thanks for the follow. Once the numbers get involved in names or like you start switching out like vowels for consonants, I tap out. Whoever you are, thank you for the follow. F must rise, of course, to become positive. Aside from that, it seems correct. Oh, critical. I was just saying that, yeah, I can probably do that problem. I'm just going to finish a discussion on this one, which I think we're nearly done with. I'm still not sure I understand what you're saying is slightly wrong, Yanis. I wouldn't be surprised if there's something that's off with my proof. I'm just trying to figure out what it is. And so I was saying before that like I was taking the simple case of a function, but I think the proof that I constructed would apply to a crazier function that does some more up and down stuff, because we're still continuous, so it can't be that crazy. Continuous and differentiable. Some x1, right? If I noticed that, I think my proof would have been a bit simpler. I kind of meandered around it. Okay, I think that's a simpler way of expressing it. That's a bit less prone to doubt. Just skip straight to the mean value theorem. Okay. I'm glad I was able to figure out the idea. But the mean value theorem, like I considered it when I first realized that we're proving things about f prime x, but I didn't see exactly how to use it until the end there. That's definitely a fun problem, though. Thanks for letting me know. And I feel like I can't give him enough shoutouts, but the reason I was able to do that problem is thanks to Zach. So. In that real analysis class. Okay, so let me erase the problem on the board, unless there's anything else that anyone else say, and we'll look at critical thinking's arc length. Some of the exams, there were some really difficult ones. Oh gosh, yeah. Yeah. If I was able to do the problem, it must not be that bad. That's kind of the measuring stick that I use for real analysis, because I'm still a real analysis noob, I think. Okay. Let's see what the problem was. To vote for anything. Oh, that's true. The time constraint does make things different. Hey, Brownie Man. What's going on? Zero is less than x less than 1/2. Okay, so we're doing arc length. Hey, Bio. The perimeter of the given acute angle triangle ABC, the interior. Oh God. I could maybe do that, but I'm doing critical thinking's problem, and then you're on deck to go next. Brownie Man, what is abstract algebra? Let me cover that quick. Well, I'm not a good person to answer what is abstract algebra. I think of it as the type of math you study if you want to go off and create your own type of math in a rigorous way. That's my very informal definition of what abstract algebra is. If you're interested in finding out more about it, Penn Center is doing this reading group. Let me show it on abstract algebra. If you're interested in finding out more about it, join Penn Center's Discord and go down to that reading group channel there. There's a PDF of the book that everyone is going through, and the first discussion stream is going to happen on Sunday. So, yeah. Also, just a general shout out to Penn Center as well, because he's awesome. About geometry, you need to, yeah, geometry is tough. All right, so critical thinking wants the arc length of this function from 0 to 1/2. So they only give us the bounds in terms of x, and this function, so what I'm doing in my head right now is I'm trying to quickly derive the function to get an idea of what it's going to look like and try to figure out how painful it's going to be to integrate it. I could see this one going either way, to be honest. I don't have a firm idea. of if working with y or x is better, but they do go to the bounds with x, and so I'm thinking just as a default, let's try using the function in this form and not turning it into x equals something with y. But I don't know if it's going to work. It's part of the exploration of integration. You have to just try things and see if they work. So let's get our dy by dx. ln darts 1 over that thing, and then chain rule times 2x. So 2x over 1 minus x squared. Now we want to integrate from 0 to 1/2 of the square root of 1 plus that thing squared. So this is what I was a little bit concerned about with why it might be easier to do it the other way around, but there could be a way to do this that I'm not quite sure of yet. So let's start by, I guess, bringing the square to the numerator and denominator. And what do we do with that? I'm thinking like we have to do trig. When you have a, God, this is kind of disgusting though. Like I'm thinking like there's Pythagorean theorem if we do cosine or sine. Oh, this might be a tricky one. We might have two different Pythagorean theorems. No, we might not. The 4 kind of messes things up. What if we just take x equals sine u and see what happens? One minus sine squared is cosine squared. Cosine squared squared is cosine to the 4th. Ew. That's a little... What is this? I thought we would get like something like 1 plus secant squared or 1 plus cotangent squared or something that can be a different Pythagorean identity, but we're actually not getting that. Yeah, this looks a little disgusting. I'm getting interested in what the alternative is if we did things with y. So we could say that this is, if we arrange that to solve for x is always positive. So it's going to be like a... e to the y equals 1 minus x squared. X is equal to the positive root 1 minus e to the y. So that square root might come in. What's happening? Oh, Phobos, yo! Thank you so much for the raid. My day is great. Hope the rest of your stream was good. And yeah, you're right. I forgot to change the bounds here. Those questions you were working on for the GRE were super fun. I'll try not to be like too pushy with like saying what my thought was, but also like very into those problems. So, but thank you so much for the raid. Working on this arc length problem from Critical Thinking in chat right now. So we do need to figure out if 0 is less than x is less than 1, what is our y? So if you plug in 0 to that, you get ln of 1 is 0. So y is also greater than 0. If you plug in 1/2, you get 1 minus 1/4 is 3/4, so just ln of 3/4. How much more we can do about that? All right, let's see what this... Oh, no. Oh, this might be horrible. I forgot we're going to have to derive it. Let's see what our dx by dy looks like. I don't really know. It's going to be a 1/2. And then chain rule times minus e to the y. I don't know about this one either. It might look a tiny bit nicer. Either way, we have a pretty disgusting integral, though, I think. So there is like the square root that can get canceled with the squared. This is what I was banking on when I was doing some like mental math on this, but I don't know if that's enough to make this integral easy. That's what you get after you square the derivative. Now what? Could say u equals 1 minus e to the y? Even 4 minus... Does that really get you anywhere, though? Not what I see. Down to 3/4 is less than 0. Shoot, you're right, Brownie. Did I mess up the bound? Why? I mean, why is 3/4 when x is 1/2? That's weird to me. Should I have actually taken the negative root? Is that what I messed up? Because the function is negative, I guess. Well, no, but x is positive. This function's always a negative. Really? Even for... Oh, yeah, because ln. Huh. It's even, though, so the plus or minus shouldn't matter. So, okay, well, really, we just flip the bounds and we're fine, I think. So that I don't think that part is the big issue. Although we do have to stick a negative sign in front of this. Oh no, we don't stick a negative sign, we just flip the bounds. But the bigger issue is how the hell do you integrate this? Let me try plugging the version with x first. So yeah, critical thinking, if this integral is too intense, I might not do every last step on the board here, because this is a little bit much. It doesn't converge? That's mean. Did I set something up wrong? Oh, critical thinking, sorry, I missed that. I plugged in x equals 1/2. Oh, good, Phobos. Yeah, please eat. Hey, Hardluck, how's it going? Oh, and Suki, I keep forgetting to tell you, but I watched the VOD of you on doing Tofu's podcasts, and I thought it was great, like super interesting. What? Let me make sure I copied the problem down right, I guess. Because the integral literally just doesn't... Oh, it's 1/2. Plugged it in wrong. Oh gosh. Inverse hyperbolic tangent? Alright. Means it can be something ugly. Wolfram wants you to expand it and get a common denominator, I assume? Do you divide them? All right, let's do the classic Wolfram Alpha cheese, where you just, whatever the next step it says, you just plug that back into the box. Yeah, I mean, that means it's gonna be something with ln's, right? Because anytime you have a hyperbolic trig functions, you can always make it e's or ln's or whatever. Oh my god. It simplifies to that? They really skip over a lot of steps there. I assume you get a common denominator, though. Really? Okay. So forget my trig sub. We know that 1 is the same as 1 minus x squared squared over 1 minus x squared squared. I'm going to save myself some writing and multiply out the numerator in my head, but we can combine them into one fraction. So we're going to have a positive x to the fourth. Oops. We're going to have minus 2x squared, which gets added to the 4x squared, so we get plus 2x squared. Then we get a positive 1. And that does factor, doesn't it? Wow. That factors to x squared plus 1 squared over 1 minus x squared squared. And now we have things squared under square root, so let's just get rid of them. X squared plus 1 over 1 minus x squared. Now, I'm not saying the problem's easy from here, but that's a big step forward. We're gonna have to do some fancy stuff with that plus 1. We're gonna have to make that like a minus, like a plus 2 minus 1 or something. Less than or equal to? Okay, critical. I'll write those in. They don't actually affect the value of the integral though, thankfully. All right, so from here, we need the numerator to be a bit simpler before we can really integrate this. So I'm gonna say that that 1 there is also the same thing as -1 plus 2. And if you're wondering why, you'll see in the next step. I'm now going to split this integral up into x squared minus 1 and the plus 2, and we're going to conveniently have a cancellation with the 1 minus x squared. Actually, I'll even write this different. With this x squared minus 1, I'm going to factor out a negative sign. Hopefully make it more clear what's happening. We don't need that space on the left. Or we need the space on the left and we don't need that writing there. All right, so this is going to cancel to be -1. It's the same thing on top and bottom, but there's the negative sign there. This, what do we do with that? Oh, do we relate to partial fractions that? Yeah, you do. Unless you want to use hyperbolic trig. So yeah, you do get a nice clean answer if you do know hyperbolic trig. I actually don't know it, so you got to do partial fractions on that. Wow, what a pain. Okay, so let's do partial fractions in a different color. Can I squeeze it in on the right side? I really don't want to put it on the left where I'm going to do other integration. I can maybe... actually, after I do the partial fractions, there won't be very many steps. So we know that 2 over 1 minus x squared. You can factor the bottom to be 2 over 1 plus x times 1... Ooh. 1 minus x, because it's the difference of two squares. And then we can... do the partial fraction decomposition, a over 1 plus x plus b over 1 minus x. I think for partial fractions that's like this, I think there's a trick to do it really quick, but I can never remember the tricks for partial fractions, so I just multiply through by the denominators and deal with the algebra. 2 equals, and I'm kind of zooming through this because it's a really long integral and we have other questions from... We have a different question from bio to get to as well, so I'm sorry that I can't that I'm not able to spend like as much time on each individual step, but I hope I'm communicating the technique to you well enough that you can follow through the algebra on your own. All right, so we have 2 equals a minus ax plus b plus bx. Now we group things based on their x's. So we have a minus a plus bx plus a plus b. So I group the x's with the x's, the constants with the constants. Now we equate coefficients. So there's no x term, so we say that 0 is equal to minus a plus b there. Then there is a constant, a plus b is equal to 2. So from this we know that a equals b. Plugging in over here, say b plus b equals 2. Well, that's not b. So we get b equals 1. And that means a equals 1 because a equals b. Okay. I should have seen that coming, right? Now that I see the answer is so simple. Hey, milk. All right. So snap back to reality. We know that 2 over 1 minus x squared is equal to 1 plus 1, or 1 over 1 plus x plus 1 over 1 minus x dx. So that part simplified to -1. This part, I mean, I don't know if it's called simplification, but this part is equal to those two fractions there. Now we have things that we know how to integrate, so let's integrate. -1 integrates to -x. 1 over 1 plus x integrates to ln, absolute value 1 plus x. This integrates to, you have to do, I'm going to do a mental u sub on 1 minus x. So I know I need to stick a negative sign in front. 1 minus x, evaluated from 0 to 1/2. Now you plug things in and hopefully we'll get the same answer as Wolfram got. -1/2 plus ln 3 over 2 minus ln 1/2. Oh, no, never mind. The 0 is fine. Okay. So that becomes 0. ln of 1 is 0. ln of 1 is 0. So there's nothing from the 0 term. So let's see if this is equal to what Wolfram got. A is -1? I don't think you should. Because then you don't get a cancellation with the x's in the numerator. Hey Shep, draw a cat? I need my channel points. You don't have any? Well, 5986, 5986. All right, it matches. ln3 minus a half. Oh, yeah, we can simplify this. We can use log identities. Yeah, Brian, I think it's supposed to be positive 1. I appreciate you checking that, though. If it's a negative 1 there, then when you get a common denominator and check your work, you don't get a cancellation on the x's, I think, is the issue. So when you have a log minus a log, that's the same thing as dividing the inside of those logs. So, I mean, well, these are both positive numbers. There's no point in doing an absolute value. 3 over 2 over 1/2, which is the 2's will cancel, and you get ln3 minus a half, which I think is what you said, right? Yeah. All right, just for you, Shep, I'll draw a cat anyway. But I'll have you know that I have the right to say no because, you know, channel points. But because you're cool, I'll do it. I want to start lower down. It's also the only way that I know how to draw a cat, so it's the drawing that you're gonna get each time you ask. Yeah, critical thinking. Well, let me know if that makes sense. So I'm like it's a pretty long problem, and I feel bad spending too much time on one problem. There's multiple people asking questions. Okay. There's a cat. Just for you, Shep. We have 1 point over Blair right now. Hey, Dumoed, it's an arc length integral. You love the cat? Awesome. Thank you so much. Okay, critical. I'm glad that we got you there. All right, so let me erase what's on the board besides the cat, and we'll look at Bio's problem. I did see there's some discussion happening in chat on it, but I wasn't able to follow it. Oh God. All right, you're getting sprayed. Bad whiteboard. Okay, cool. All right, what's happening? For this scene, draw every integral symbol as the tail of the cat. Sound is lagging? Oh, shoot. I think I figured out the fix for it, but it's kind of annoying. You know, that's stretching the intent of of that redeem a bit, but that does sound kind of funny, so let's do it. All right, hopefully the music is fixed. Second one is easier, but you can start with whatever. Okay, bio. So let me scroll up in chat. Can't do that. You can first try this one. Let me copy paste it. Wait, is equal to... Oh, okay. The question is what it's equal to. Can't say we're going back to bed? All right, Chip. I'm glad that you like the cat. But B and C be the tangent points. Wait, be tangent points from the point 6, 0 to the circle. Oh my gosh. What's happening here? So you have a circle of radius 3, centered at 1, 0. So that never reaches 6 here. Oh. Really? That's... Yeah, I'm drawing a picture of this. Because this is like a calculus... I mean, the questions like this are commonly asked in a calculus class. But I don't think bio is supposed to be doing things with derivatives like this. Or I think there's supposed to be some kind of geometric way to solve this problem. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. 1, 2. So the circle is centered at 1, 0. It has radius 3, so we want to go there. 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 Now we have this point off to the side here, A, 6, 0. And there's two tangents to the circle through the point A. One that goes up there like that, and one that goes over there. Oh god, like that. That's more like a tangent curve, but you know. We can call that one arbitrarily B and that one arbitrarily C. And we need the length from B to C? So, if I was doing this problem in a vacuum, like I'd probably do it the long and hard way. That's what she said, which is using calculus to figure out the equations for these two lines, figuring out where the lines intersect with a circle, and then getting the distance between those 2 points. But I don't think bio is supposed to do it like that. It's y squared and x minus 1 squared. Oh, yeah, bio. That's how I interpreted it. Hey, I have no idea how you pronounce that, but person on YouTube looks like... I mean, I know it's Cyrillic. I'm going to call you Poma Meow. Hope you have a good day, too. I'm sure that's exactly how your name's supposed to be pronounced. So how'd you get... It forms an isosceles triangle, right? I didn't draw it right, but I would expect this to be an isosceles triangle. ABC. So a tangent line means it only passes the curve through one point. They are related to right angles, but it's not like the line makes a right angle with a circle. The line makes a right angle with like the radius or the diameter of a circle though. So that that's just like you have to know the general form of a circle. Oh, that's what you're saying, Brownie? All right, I'm sorry that I misinterpreted you. So yeah, what you're saying is true then. So there's a... This is a bad explanation. If you're given an equation like this, then whatever you're subtracting from x is the center coordinate of the circle in x. Whatever you're subtracting from the y is the center of the circle in the y. And r squared is the square of the radius. So we had 9, so you take the square root of that to get the radius 3. So that's how you draw a circle. So since it was x minus 1 squared, the x coordinate of the center is 1. Since it was just y squared, the y coordinate of the center there is 0. So based on that 3, right. Ooh, Brownie. That's a thought right there. That we can get 2 right triangles out of this. If we go from, I guess we'll call the center D, why not? That's supposed to be, well, okay, wait. So DBA is a right triangle. ACD is a right triangle, because like, that's right. And that's right. We know the length of AD, because it's the distance from 6, 0 to 1, 0. Ooh. Ooh. We don't know. Oh my god, yeah. Oh my, dude. Genius. Because BD and CD are both 3. Okay. I'm picking up what you're putting down now. Okay, dude. Yeah, that's just the answer there. Okay, so we have to use okay, so let me back up and explain it before I get too much in the weeds. Where is it 3 on the x or y axis? Okay, so yeah, let me not... I'll back all the way up here, Bio, because I don't want to leave you behind when I start like solving the problem. I'll start with drawing the circle because it sounds like you're asking about that. And then we'll get into how we solve the problem. Okay, so just looking at the equation of the circle, we know the center is 1, 0. And I know that because it's x minus 1, and that minus 1 becomes positive 1 for the x coordinate, because it's just the way that circles work, I guess. And y doesn't have anything subtracting it, so it's just 0. And I think you already understand that part. The radius, that's a nice spell, radius, is 3, because we have the square root of 9. So when we go to draw this, we now have all the information we need. So I'll go out 1 to get to the center. I'll go out 3 more because the radius is 3. So 1, 2, 3 more. So our center is here. The radius being 3 means you go out 3 in all directions. I just do, up, down, left, right. And I kind of fill in the rest. So 1, 2, 3, 1, 2, 1, 2, 3. So if you go to the right 3, you end up here. If you go up 3, you go here. If you go to the left 3, you go here. If you go down 3, you go here. Now we connect these 4 dots with a circle. And then we're also given a different point A, which is 6, 0. So let's draw that in too. So are you with me so far for my drawing bio? I haven't gotten to the tangent points yet, but you get it? Okay, cool. So now, if you have a tangent to a circle, a tangent is any line that just touches the circle once. So like, you know, it's a line that goes like that, it's a line that goes like that, it's a line that goes like that. But we're interested in the tangents that go through this point A. So it takes some kind of visualization, but if you have to go through that point A, you either have a tangent that's like that, or a tangent that's like that. So I just kind of drew those in. There's no other way that you can have a tangent line going through A. It doesn't really look like it, but you know, just pretend it intersects there. And then you also have a tangent line like that. They intersect right there. And I don't think they tell us which one is which, so let's just call one B and one C. I don't think it really matters. And we're interested in the length, wow, BC. Is it going down or up through A? Well, it's both. There's 2 possible tangent lines, bio. And that's kind of like what the problem is based on. So we have a tangent line going up like that and a tangent line going down like that. You get it? Okay, cool. And hello to, how do you pronounce your name over on YouTube? Okay, so now we have to use, if a tangent, let me actually draw this to the side. If you have any circle with a center there and a tangent line there, if you draw the line from the center to the tangent line, that forms a right angle. That's the idea that we're using for this problem, that any line from the center to the tangent line, well, the shortest line from the center to the tangent is a right angle. And this is how we're going to get right triangles. Not quite yet, bio, because we don't know where B and C actually are. And I see LOL over on YouTube as well. You have a question. Y cube root equals x to the, and y equals x to the root of n. You need to find the value. I'm not sure what's happening with that question, LOL. I can look more at it after I'm done with this one, though, if you have a minute. So yeah, so I'm going to use the same idea over here. I'm going to connect D to B and D to C, because we don't know that's where B and C actually are. If we did know that, the problem would be a lot easier. So I've connected those. That means we have a right angle there and a right angle there. So triangle ABD is right, and triangle ACD is right. And now that we know that there's, like, you know, a right triangle up there and a right triangle down there, we can do some Pythagorean theorem stuff, which we need to figure out some values, though. Oh, I've been calling it D. It's pretty common to use O as well. They're just letters, Bode. Oh, but you're right. O is normally used for the center of a circle, but how do you explain transform Normal quadratic form to vertex form. I can cover that too. Person's name I don't know how to pronounce. But you're going to be on. The short answer is you complete the. You do something called completing the square. And I can actually show you how to do that if you're willing to wait until after I do this question and then LOLs. Plus another one for bio. Shoot. Sorry, there's a bit of a backlog right now. Actually, I might have to wait on bio's second question and try and quickly get through the two on YouTube. Okay, so but bio, back to this problem. We want to do the Pythagorean. So, oh wait, how does this problem work? We can figure out. I just realized we want the distance b to c, right? So actually, this isn't going to be the final answer. We have some more work to do after this. Yeah, we want BC. Okay. BC is normal to AD. That makes sense. But we don't know where BC, like we still don't know the bottom length. And I don't know, like I think you're missing two of the sides. Oh, I guess, no, you can figure it out by looking at the left side. Okay. All right, so first, but before we get too deep in the weeds, let's name the lengths that we do know here. So BD and CD are both radii of the circle. That means they're 3 because we know the circle is radius 3. Right, so we got a 3 there and a 3 there. The distance from A to D, well, A is 6, 0, D is 1, 0, so 6 minus 1 is 5. So AD is length 5. So I'm just going to draw this like stuff off to the side here. I don't think we even need the circle now as much. We have a shape like that. 3, 3. The entire thing is 5. I mean, for AD, it's just 6 minus 1. You can do the entire distance formula, but they're on a straight line, so... Or they're both on the x-axis, so you just do 6 minus 1. Okay, so... since we know... We can work out the length of AB in AC now with Pythagorean theorem, because we know... We know that if you look just at like a... Oh my god, I'm going to draw yet a third thing. I'm going to draw ABD, I guess. A, B, D. DB is 3. AD we said is 5. So by Pythagorean theorem, we can work out that last side. And actually, I just happen to know that's 4. So AB is 4, and by the same logic, AC is 4. But, you know, you would do square root 5 squared minus 3 squared, and you'll end up with 4. $367 divided by 67. Pink Fluffy, that's a problem for Wolfram Alpha or a calculator. I don't know. It's probably a decimal. Okay, so we know 4 and 4. Do we get a system of equations out of this? Because the length from like this part and this part add up to 5. Oh, what? Yeah. Or is there a quicker way? Thanks. Oh, I'm not sure I even really helped you, Pink Fluffy, but yeah, I do that with a calculator, to be honest. Similarity? I mean, how do we know that these triangle, like, or what about similarity, I guess? Use the fact that am squared equals am times md. It's from the theorem. We call m the intersection. Probably not equilateral. am squared equals am times md. Am squared. I already... Does that mean am equals md? Oh, okay, I was like, mb squared. mb squared is am times md? mb squared is am times md. That doesn't seem unreasonable. What is that called, though? I don't know what you're saying is an equilateral triangle. These are right triangles, and right triangles cannot be equilateral. I don't think. Yeah, they can't be. Did you already say what that was called? Right triangle altitude theorem, Bode? Is that what you're using there? Okay. That is a... We don't know AM or MD, that was the issue. We know they add to 5. But we, like, you could say that, like, you know, one is x and one is 5 minus x, but we need to solve for that x somehow, right? Gosh, what's happening? DMB is similar to DBA. I don't see that. I guess they share a right angle, they share another angle, and they share a side, so angle, angle, side. It's not the same angle and side, though. Isosceles triangle? Yeah, it's possible to have an isosceles here. We very well might have one, to be honest. Or 2 of them, I guess. Or 3. I mean, probably, you know, we have a lot of isosceles triangles. Rotagon, again, Ron, you hate the letters. AB squared is BC We don't know enough to do formulas with isosceles triangles. We need an angle to do formulas as far as I know. Triangles share students must share a third angle. Oh. Yeah, I guess you're right. Okay. You're right, Brownie. The one you wrote last is correct. AB squared is AM times AD. Huh. That seems like it can't possibly be right, but maybe it is. I was trying to think about like visually with the actual lengths of the segments. But Brownie's thing with similar triangles might be more convenient. Because I think what Brownie is saying is we take, you know, I'll just like redraw that triangle over here. Draw it lopsided. If you take the perpendicular from there, like we do have over here, and call it M, I think Brownie's saying that a triangle ABD is similar to BDM. Because they share angle D, they share a right angle, so their third angle must also match. So angle, angle, angle. And we know 3, 4, 5. So if we figure out what sides correspond to what, then aren't we in business? Oh wait, you don't know how, oh no, you need a, oh no, you do have a side. Okay, so I need to draw this, I need to rotate them so that they're the same way. Because it's always so hard to visualize what sides are corresponding. So B is the right angle for that one. A is the long side. D is the short side. 3, 4, 5. Now if we take BDM, now M is the right angle. The hypotenuse is 3. Taking that and we're just flipping it over. So D is over here and B is up there? And since we know they're similar, we have enough information to get BM, which is half of BC. Okay. So we know that 3 over BM is 5 over 4, right? If I set these proportions up right? So BM is 3 times 4 over 5, which is 12 over 5. Does that make sense? That's slightly less than 3, so that seems reasonable. So we know that BC is equal to 2 times BM. So that's 24 over 5 is the answer, Bio? I think. Okay. Person on YouTube army we need to find. The problem was to find BC. And Daisy, Cynthia, hello to you. I don't know what you're saying, but hi. So I hope that makes sense, Bio. Hey, Atharv, how's it going? Let me look at what people were asking on YouTube. So, LOLOL, are you still here by any chance? It's been a while, so I understand if not. I think it's the first person who asked a question that I wasn't able to get to immediately. The topic indices, it's y cubed root equals x to the root of 6. And y equals x to the root of n. Oh, I see. So it'll be some, just like some rearrangement of the exponents. Let me know if you're still here and happy to work through that problem for you. LOL. You don't get the two triangles are similar? Bio, that's because it's angle at angle angle, isn't it, Brownie? It's because I should really draw the angle here. So it's because we're arguing that all three angles are the same. So they both have a right angle. That part of it is, I hope, easy to see. Both these triangles share angle D here. And since the angles in a triangle add to 180, it's going to be the same thing for this angle up here versus angle A over there, because the other two angles are equal, so the third angle must be equal too. So we're saying they're similar by angle, angle, angle. I didn't see it. That was thanks to chat. Senor Sasquatch, two identical pendula are coupled by a spring and are oscillating. When is the position? Ooh. The normal modes? I'm not sure exactly how you do that, Senor Sasquatch. Maybe I could look it up and remember if I had enough time, but there's some people that asked a question before you that I need to get to first. And Atharv, make a question to get the sum of roots of a general quadratic equation with non-imaginary roots. Yeah, if I can get through other people's questions first, I'll try and Google it for you if you're still around by that time, but I'm not sure when that's going to be, because yeah. Make out a question to get the sum of roots of a general with non-imaginary root. Would you just do the quadratic formula and add the two different pluses and minus? Atharv, that's kind of my quick answer, is to use the quadratic formula to express each of the two roots and just stick a plus sign between them. But I can try and explain it more if I or I can try to explain it more later, I guess. So I still don't know how to pronounce your name, person whose name is in Cyrillic, like upside down HEPHNX, backwards N. Can you explain how to transform normal quadratic form to vertex form? I can. Are you still here? You are still here. Okay, cool. Oh, there's also something called Vieta's equations that might come in handy with that. They might be intended to use Atharv. But let me focus on your question first. It might just be minus b over a. You're right. I just don't know them offhand. So, okay, but focusing first on the question, transforming quadratic equation into vertex form. You do that through a process called completing the square. If you have a specific problem you want to see me transform into vertex form, let me know. If not, I'm going to make one up. Either way is fine with me. Oh shoot, I almost erased the cat. That would have been terrible. Okay. Check chat. Make yours? Okay, sounds good. So if you just are given a quadratic like let's say y equals x squared plus 2x plus 3. So that's not factorable, but even then it's not important for the sake of doing this. You need to do something called completing the square, which is the idea of completing the square is you want to transform this into something like x, plus some number squared. But not every equation can just be like that. You have to have like something off to the side to like compensate for it, because not every equation is a perfect square. And the whole idea of like figuring out how to put this equation into that form is called completing the square. And this little like formula that's handy here, which is I remember this kind of like in an intuitive way, so it's hard for me to like say the actual formula offhand. I believe it's if your coefficients here are A, B, and C, what you want to do, the thing that you want to like add, you need to do like an adding and subtracting thing. And the thing you want to add and subtract is B over 2A. Right. So B is 2 and A is 1. So we get, oh my gosh, it's supposed to be an arrow. So we get 2 over 2 times 1 is just 1, because 2 divided by 2 is 1. So what we're going to do with this equation is we're going to do plus 1 and minus 1. 2x plus 1 minus 1 plus 3. So we haven't actually changed the nature of this equation at all, because plus 1 and minus 1 is 0. So you haven't actually changed any value. But now it's in a form where we can focus just on that part, and that's a perfect square. And it's engineered specifically to turn that away because of this formula here. Like, that'll always be a perfect square as long as you did that part right. So that part in red becomes x plus 1 squared. Left over, we have a minus 1 and a plus 3, which becomes plus 2. And your original question was how to go from quadratic form to vertex form. This is vertex form. The vertex of this parabola, the general vertex form, x minus h squared plus k, a is 1, h is negative 1 because there's a minus sign there, and then k is 2. So I'd say the vertex of this parabola is negative 1, 2. Let me know if that makes sense. Proof for cosine 36. Oh, wow. Wow, that's a lot of work. Okay. Let's use a vertex form over quadratic form. Vertex form is nice for graphing, especially. Like, if you just have that to graph, I don't know how you do it. Like, you can easily plug in 0 for x and get 3. But that's only 1 point. You don't really know how the rest of the parabola looks. This gives you a lot of information about how you graph it. So, I could even just graph it quickly here to demonstrate. We know our vertex is negative 1, 2, which is a really helpful point for graphing a parabola, because you know that's the peak or the valley. So our vertex is at negative 1, 2. And a is +1, so a positive a means that the parabola opens upward. The parabola is going to look something like that. Oh god, that, well, you should actually go through the vertex, but it gives you a much firmer idea of how your parabola actually looks. That's the main purpose of a vertex form, I'd say. Normally, I just would rather have it in quadratic form like that, or like factored. But that one doesn't actually factor, though. Vertex forms quicker to find the zeros. Oh, yeah. It's true, too. XD. Oh, yeah, it's also good for symmetry. So you have to do some problem involving like the symmetry of a parabola. The vertex form is nice because parabolas are symmetric around their vertex. So let me know if there's any questions on that. Okay, so next in the YouTube chat, there's that division question that we got to quickly. I guess we are on Senor Sasquatch's question, if you are still here. But I still don't really remember this stuff offhand. The angular frequencies of the normal modes omega, that might be rho or p, and omega b. Actually, I don't remember the term normal modes. If I did learn those. Angular frequency normal mode. If I can just find a formula to plug into, I can probably do this. Omega 1 squared is g over L, omega 2 squared is g over L plus 2 kappa over... well, what do all these mean? That's probably skipping straight to the end, right? See if I find a different explanation. And this doesn't look like high school physics to me. It's like calculus-based physics. The system is two identical pendula are coupled by a spring, which that's definitely not an algebra-based question, I don't think. Probably too complex. I'll copy over the question from YouTube chat into Twitch chat. I don't know if this person is still here anyway, so I might just kind of sneakily leave it alone. But it'd be cool if we could figure out. Oh, you are here, Senior Sasquatch. It's a symmetric couples with SHOs, so it's cool if it's not good for here. Yeah, the more I look at it, the more complicated it looks. I was hoping that it'd be some kind of clean formula. It doesn't seem like it is, though. So maybe there's someone around in like the Twitch chat who happens to know. So, I dual stream to YouTube and Twitch at the same time. But this is kind of a little bit out of the wheelhouse of what I do, I guess. Because I did learn about like coupled systems a little bit. I just don't remember it very well. Give me your notes. Okay, yeah, I mean, if it's a formula I can plug into, I can definitely like blindly execute the math. The concepts I definitely am not gonna be able to quickly learn. And Athar, what's the minimum value of a squared plus b squared plus c squared over ab plus bc plus ca? That sounds like a really tough question, Atharv. Does that come from something? Oh yeah, Bo, you were doing some inequality ones I remember a while ago. ABC are positive real numbers. Yeah, Bo, if you have a solution, I don't know how you do that. Copy paste it over just so you can see the exact form of it too. I assume the denominator's in parentheses. A, B, C are positive real numbers. Okay. Because I think like you probably need calculus for that or something. But the calculus of that would be really annoying. Arithmetic mean to geometric mean? Oh god. Arithmetic mean is greater than geometric mean. I'm sorry, I have to use the bathroom right now. I'm gonna put on my BRB screen. I'll be back in like two minutes. And that hopefully Bode will be able to work out your problems. I think Bode's worked on a lot of similar problems. I'm gonna have to do some Googling on this, I guess, hint that they gave me to figure it out, but I'll be right back. Arthav. Oh shoot, you had to go. Well, sorry if we took too long. Hope you sleep well though. Looks like Bo is putting the solution in chat if you do happen to still be around. Bo is saying the answer is just one. Just use this fact. A squared plus B squared plus C squared is greater than or equal to AB plus BC plus CA. The thing really hard to prove this, multiplied by 2, you get 3 perfect squares. It's one solution, another is with Chebyshev. Arrangement inequality. Cauchy-Schwarz inequality, another with Holder. Oh gosh. 10 solutions to this problem? 73 distinct solutions? Oh my god. Multiply by 2 and you get 3 perfect squares? I'm not really following that, but I'll paste it over to the YouTube chat just in case Arthav comes back and checks the VOD or something. I'm not really following the argument though. Oh. Interesting. And Sasquatch, I'm seeing that your squares are always greater or equal to 0. Huh. Okay. I don't know how you get 1 out of that, but that's an interesting rearrangement. So Sasquatch, you're saying omega p is square root g over L, omega b is square root g over L plus 2k over m. That was the cap. Okay, so I didn't see those. L, M, and K are the exact same. We don't need to know their exact value. Yes. So we're given the position function in your system here for one of, or well, we're only given one of the position functions for one of the masses. So is the length going to be the amplitude, which I assume is 2? Like we're getting as many of the constants as we can. K is the spring constant, M is the mass. Are we able to figure out the mass from the position function that we're given? Because I don't know what else would do for the problem if we're not just finding, I mean, G is a given, but if we're not finding L, K, and M, I guess. Hey, Quack, 2020p3, I have no idea what that means. I don't see a link to the problem. Can you just type it out in chat there or something? I don't think links, I don't think, can you even put links in YouTube chat? I think they're turned off. Or you can take a screenshot and put it in my Discord. Yeah, I don't see a link. Sorry about that. Standard pendulums. Oh, really? Oh, gosh. Honestly, I was wondering if that was like a translation thing or something, so I was kind of assuming that it was something like that. Two pendulums connected by a string? Or two pendulums with masses on their end, and the masses are connected by a spring. That's a weird one. I still don't see what you put, Quack. Oh gosh. I'm Oh, okay. So you're saying A, B, C, D are positive real numbers satisfying that. Oh wow, that's another one like Bode works on. I don't know how exactly you do those problems. There might be someone I mean, Bode, I don't mean to call you out. You don't have to do anything you don't want to, but that's the problem that just happened there. I don't know how you do this offhand, but we might be able to figure it out. I'm going to switch back to looking into Senior Sasquatch's question, but you think you've solved this one? Okay. And no pressure if not. Like, if you're just trying to chill and not do too much math, I completely understand. So, Quack, I'll take a harder look at this after I can hopefully either resolve or give up on Senior Sasquatch's question. I hope that I can actually figure it out, though. I mean, this seems relevant. U and V are the normal modes. Hmm. Yeah, I'm sorry, Sasquatch. I thought I'm able to handle this one, but it's a little bit too much for me. I'm not. It's taking me too long to figure out what's happening here, I think. Yeah, sorry, because it does look interesting, but I'm not sure. This PDF does seem like it might be kind of helpful, so I'll drop the link in chat. But yeah, I'm not good enough with this type of stuff. If you have heard of Twitch, there's a streamer who might be able to help. Actually, there's two, I guess, who might be able to help. They're a bit more physicsy than I am. Am I able to do? I don't think I'm able to do shoutouts on YouTube. Let me I can't promise anything because I don't know if they've done this specific type of problem before, but actual education and physics and depression are a bit better with physics. I really hate to like call them out for something because I don't know that they can do this stuff, but those are kind of like the best people I can think of who might be able to handle it. But yeah. Okay, so yeah, no problem, Sasquatch, and thanks so much for coming and asking a question. I wish I could help out more, but that's the best that I got for you, I think. Would you get common denominators here or something? You solved it, Bode? Oh, thank God. I was still just like... It's in chat? Okay. Let's look at what the answer is. So, Quack, if you open up my Discord again, Bode kindly put the answer in chat. And I'm going to bring it up on stream here, too. Because I'm curious to see how you even do... Or how you do a problem like this. So you say it's... Oh. AM minus GM? Oh, arithmetic mean minus geometric mean? Okay. Or plus, okay. Put up on browser? Okay, yeah. Arithmetic mean plus geometric mean, like something like this, hopefully. Not plus, just inequality. Okay. I'm just gonna say versus. Oh, that's the geometric mean to the 1 over n. Oh, it's AM like hyphen GM, not minus. Okay, that's what you meant, like just... You're not literally subtracting them. I see. Arithmetic mean is always equal or bigger than geometric mean. So... For two elements, you always have... Oh, okay, so you're rearranging that inequality there specifically for two elements. Okay. So... oh, gosh. So you took AB and AB, we don't, AB and A over B and C over D. you said a over b plus c over d is greater than or equal to 2 square root of those multiplied, which is the geometric mean. Or that's using that like relationship that you said. You took b over c and d over a, and said that's also greater than or equal to 2 times the geometric mean. Okay, so I'm on board with that. Now here, I assume you get a common denominator, and that's why the square root goes away on top. Okay. Wow. And then now you apply the given information. Okay, from thing, I like that. And this is probably another arithmetic mean to geometric. Yeah, it is. Okay. And you end up getting a cancellation with the root A, B, C, D's, and you get just 8. Wow, that's crazy. Those problems. Getting back to the person in Discord, I haven't seen them put anything in the YouTube chat, but thank you so much for solving that, Bo, because that's such a weird inequality to solve. You know, I never had to do questions like these before, so I don't know the techniques, I guess. Okay. Well, it's been 2 hours of just questions from chat, which is great. I absolutely love having questions from chat rather than having to find them on the internet. Actually, oh, Bio, you did ask a second one. I kind of forgot about it. Are you still around, Bio, and do you want to talk about your first question? Let me pull up what Bio's question was. /user messages. Here it is. I don't know which I dislike more, the geometry or the binomial theorem. I'll type to Bio in chat too in case he doesn't have the audio on or he comes back later or something. Okay, so I see what you put, but let me try to wrap my head around the question first, and then I'll look more at what you just said. In an acute angled triangle ABC, the interior angle bisector at vertex A intersects side BC at point D. If AB equals AT equals DC on the perimeter. Okay, let me draw this out. So it's a cute angle, so I'll draw something. I mean, I shouldn't make it literally look equilateral, but it'll be something like equilateral-ish. I should draw it bigger, right? You know, I have this entire whiteboard to play around with. We're gonna have to do some drawing inside stuff, so. That's, I don't know if that's quite a cute, but it's close enough. ABC. Oh no, we haven't done any integrals, Anders. If we don't have any come up, I'll refund your points, I guess. Interior angle bisector. Yeah, sorry. So we're gonna bisect this angle A. Call it point D. AB equals AD equals DC equals 2. AB is 2. AD and DC are also 2. Really? So that's an isosceles triangle in the upper left. And we want the perimeter of the entire triangle. So this is not necessarily bisected. Wow. Yeah, we need some interior angle theorem. Or bisector, angle bisector theorem type thing. Yeah, I was just wondering how you find the angles in the first place. Like, do we even, like, okay, yeah, so this is what I was thinking of. The sides are divided in proportion. But we don't actually have, we only have 2 of the sides involved in this. I mean, how do we use trig? We don't have any right angles. Like, law of cosines can maybe come into play here, but we need another side length, don't we? Oh, maybe you can get an equation, a system of equations with law of cosines, is what you're saying? I mean, so I don't know if it's going to be helpful. Let's at least write out the angle bisector theorem as well. Just see what relationship it gives us. It's 2 over AC equals BD over 2, right? So those two are like inversely proportional. Actually, well, yeah, I guess so. So I don't know if that helps us, but... So if we want to use law of cosines here, like... what do we, like, BD squared is 4 plus 4 is 8 minus 2 times 2 times 2. BAD. Then you could do law of cosines on the entire big triangle and say that I guess we'll do like that as the side we want to find. BD plus 2 squared is equal to 4 plus AC squared. I'm just kind of writing things out because I'm not really sure where this is going. We do know these are, BAD is 1/2 BAC. We still have, I guess we need to maybe do law of cosines on this other triangle too. Then we always have 3 equations. Find the angles first. How do we find any of these angles? We have 2 unknowns in each of these equations individually. If you do law of cosines over there, 4 equals 4 plus AC squared minus. Right? And since we know it's angle bisector, we can get it so it's 3 equations, 3 unknowns. Not a simple thing still. Hey there, CH Zain Abbas. Equilateral triangles? I don't know how we get that. They do share an angle and they share a side. Hey, critical. 180 minus 2a for BAD. Wait, so DBA is A? You're saying DAC. How do you say that's true? Hey, Viv. I'm not even following your first. Like DAC is 180 minus 2A? Oh, if it's a supplementary angle? Okay, yeah, because I'm struggling here. DBA is A. Okay. BAD is 180 minus 2A. You already lost me there. Are you saying that DBA is equal to BDA? I definitely don't see how we get an equilateral triangle. 2 equals 2? What? Wait. So, Bode, you're saying DBA. Why do I write M? Is equal to 180 minus 2 BAD? Or no, BAD, I have that backwards. I guess that's also true though if you rearrange it, but let me write exactly what you wrote without the A, because that's, I guess, also tripping me up. AB equals AD. Isosceles triangles, two sides are the same. Equilaterals, all three. But you're right, we do have isosceles triangles here, which I didn't really even think about. Let me try and work through what Bode is saying, though. So BAD is 180 minus 2 dBA. BAD is 180 minus 2 dBA. So you're saying this angle and that angle are the same because it's isosceles. Okay, now I get it. Okay. And then you do the same thing with CAD. Okay. Well, you're saying dBA is the same as CAD. BAD equals CAD. But dBA was A. It's like your second line. Whoa, wait, okay. Now it's CAD. You're also saying is 180 minus 2 dBA? Let me figure out. CAD. So basically, say, like, you know, those two angles are. Oh, duh. Okay. Because BAD. Okay. Because they're bisected. CDA is 180 minus BDA. CDA is 180 minus BDA. Supplementary, yes. Is one. Hey, Cloud. Do I still have my copy paste? Let's see. I do. You want the perimeter of the big triangle. BAD equals CAD. Wait, okay, so where am I in your work? CAD is 180 minus 2 dBA. Okay, yeah. But CDA is 180 minus BDA. Okay. dBA? Oh, I thought you were using supplementary angles here and here. Is that not what you're doing in your third step? Well, dBA... Oh, God. Oh, they are the same, because isosceles. Okay. Yeah. Because these are supplementary angles. And then this one is the same as that one because it's isosceles. Okay. Gosh. So, okay. Or sorry, BDA, not BAD. Or no. DBA. Why do I keep putting M's? M is nowhere in this problem. Okay. DBA. Okay, yeah. I guess you're right, Build. Yeah, I'm seeing why. So what do we do with this? We have BAD, we have CAD, we have CDA. Okay, let me look back at what else you've said in chat. AB equals AD. Oh, you're seeing that for the isosceles part, yeah? ADC. Wait, CAD. Okay, so now you're saying CAD equals ACD. By isosceles, yes. Two ACD plus CDA. Okay. I should actually, let's fill in angles for my isosceles triangles. Oh. Those three are all the same, and then these two are the same. Two ACD, right, plus CDA. Okay. I'm on board with that. Then just replace. 180 minus dBA. CAD is the same as ACD, so we can, okay. So we use this fact and this fact. What a crazy I would never have thought to do something like this. Like, wow. You're saying that's 72? Don't agree with the 7. I agree with the 2. Okay. So dBA is 72. What does that get us? dBA. That gets us one of the angles of the big triangle. It gets us the angle A here indirectly, so that we get the angle C. Okay, so we have all the angles. And then we can do law of cosines? Is that the point? Olympia geometry. Oh god, I don't like geometry. Hey Hassan over on YouTube, how's it going? All right, so 72 and 72. 2 times 72 is 144. So 180 minus 144 is 36. This entire thing is I saw, like, that is equal to that? Because angle A is bisected. That happens to be 72 also. Because you do 180 minus 2 times 72 to get that, which happens to be 36, and then you multiply 36 times 2 again, which is 72. Wow. Yeah, I probably did make it harder for myself with all the letters. So let me see what I guess the issue is now with your, or like for why we want to do that entire thing that you're saying, Bode. So if we want to law of cosines this, I mean, we know that 72 and 72, so we can make our law of cosines a lot simpler, right? If we want to solve for this side, I guess, can we say that AC squared no. Yes? Wait, okay. These two are the base angles. So this is equal to that. So AC squared is equal to AC squared, which feels very weird to me, plus AB squared is 2. Minus 2 or AC squared cosine of 72. Can we solve that for AC? You gotta go, Bode? All right, no worries. Thank you so much for your help. And I'll work through the stuff that you said once I realize what my mistake is, probably. But like, is there something wrong? I wonder if there's something wrong with this, or like, I think I'm using the fact that it's isosceles to my advantage, but I think I'm applying a lot of cosines, right? Wow. Simplifying cosine of 36 like this? But for the way that I did it, we don't get cosine of 72, I guess. See if we get similar things. A simpler way to find the angles? Oh, really, Cloud? Sounds nice. What is it? This looks kind of comparable, I guess. I don't think bio's here, so maybe I won't worry too much about getting to the end result. But if you have a better way to do it, Cloud, I'm all ears. So I think after this point you'd be done, because this is the length of AC. Just multiply it by 2 and add 2, and that's your answer. Oh, all right, that's you. Just DM'd me. Let's see. Oh, we're not just deep into trig sadness, Stookie. We're deep into geometry sadness. But no, I am, because Bo basically hard carried me through this problem. And Cloud is saying there might be an even easier way than Boda was suggesting. I'm about to bring that up now. They work out that those are both 2 alpha over there. I guess that's simpler, Cloud. You're right, yeah. 180 minus 180 minus 2 alpha. It is annoying, Yanis. I don't like it at all. Because I feel like in the real world, you just use a compass and a straight edge, or, you know, just measure it. And be done with it. All right, so yeah, that's a fair enough, Cloud. We still have a bit of work to do to actually get to an answer, but that's kind of like the. I mean, the problem has a couple of hard parts, but thank you for the alternative way of doing it. But yeah, either way, bio isn't. I don't think bio's here, so I'll just kind of leave that one there, I think. We don't have anyone else in chat asking questions as far as I know. So now 2.5 hours in, we'll try and do some abstract algebra. Plus one for more abstract algebra. Oh gosh, I don't want to learn it, but Penn Center is doing the reading group, and like I haven't talked about it too much, but it has been a goal of mine to do grad school, and like, you know, you're just studying for the GREs, and it's like the algebra and the analysis part when I took the GRE was like the worst part for me, so I never took a class in either of them. So I was like, oh, that's probably a good opportunity to actually learn some algebra. You like algebra, Yanis? Yeah, I'm sorry. This is just like it's just a little bit too abstract for me, I guess. And that's just it's called abstract algebra. It's not really the algebra's fault. Silo theorems. Hey, underscore. So yeah, Penn Center's reading group is only like just barely starting. So we're starting with the preliminaries. I tried this a little bit on Thursday, but we didn't get very far at all before someone asked a question, which is, I mean, I'm not complaining about people asking me questions. We looked at the well-ordering principle. We looked a little bit at division algorithm. I kind of skipped over the proof, which I looked at off stream, and I think I'm okay with it. I wouldn't have come with it on my own, but I think I understand it at least. I think I looked a little bit at this off stream, that the GCD is no, the linear combination part is down here, but defining what the GCD is, and then saying that you can express it as a linear combination of those two numbers I'm on board with, I think. So this I didn't look at, but it makes sense. If A and B are relatively prime, then there exists integers s and t such that as plus bt equals 1. That's basically another way of saying their GCD is 1. Okay. P divides AB. If P is a prime and divides AB, then P divides A or P divides B. I think underscore and Yanis, you guys both helped me out with a question like a week or two ago that involved this. P's prime divides AB, does not divide A. But if P is not a prime, how does this break? Can P divide neither of them? That doesn't make sense. Or does it? If, say, A is 6 and B is 3. Oh, it doesn't divide them individually. Okay, that's fair. So like 9 divides 18, but 9 doesn't divide 6 or 3. Okay. It's kind of crazy how that works, but I guess it makes sense. Okay. Fundamental theorem of arithmetic. Hmm. And also least common multiple. Oh, that's right. And like the algorithm is you take their prime factorizations and you take like you discard the duplicates basically. So like the 3 squared. It's not a good way of phrasing it, but like if there's 2 things in common, you take the higher power, I guess. Hey, Ben. Myth? Mm-hmm. Okay. So that's the first section on properties of integers. Okay. And now we're on to modular arithmetic, which I'm not very strong on either. Shit, I feel like I should zoom in slightly more, right? Actually, it's the browser is off. Oh, I didn't even notice that. Oops. There we go. Hope this wasn't too annoying. Oh yeah, like it's just like it's the browser was like turned on, but it wasn't yeah. Okay, this is a nice like example of modular arithmetic. I like that. In this mod notation, I had to learn a little bit, but once things started to be congruent to other things, modulo other things, I had no idea what you do with that. So yeah, that's right. A divided by something, or A mod something gives you the remainder. A divided by that thing would give you Q. Well, if you're working with integers only, I guess. Three mod 2 is 1, since 3 is equal to 1 times 2 plus 1. Right? Negative. Okay, wait, yeah. So we have the 2 special cases down here. So yeah, if you have like, if your fraction, because I always think of this as like division with fraction. So if your fraction is less than 1, you just get the numerator back out because it's like a decimal that's less than 1. So just the entire thing is a remainder. Okay. You have a negative number. I'm actually not really familiar with this. It's 13. Since Q doesn't necessarily have to be positive. Okay. So now if you had negative 2 mod negative 15, will that just turn positive again? It would be negative 2. Because it'd be like this case up here. Okay. If a and b are integers and n is a positive integer, then a mod n equals b mod n if and only if n divides a minus b. And the proof of that is in exercise 7. Okay. You know what? Maybe that's not that bad. That might be a fun proof to actually try, because I assume it'll be something not that bad if you use this form. But let's not get too ahead of ourselves. Addition, multiplication mod n should be ab mod n, or a plus b mod n, or a or b is greater than n. It is easier to mod first. (27 times 36 mod 11). We know that 27 mod 11 is 5. 36 mod 11 is 3. It's equal to 5 times 3 mod 11. You have to wait. You mod them twice. You mod each individually, and then you mod the result. Huh. Okay. So I would think you just take the 5 times 3 and you're home free, but evidently not. Oh, maybe, I guess I kind of get why. I can't really explain it, but the 5, no, I don't get it. Never mind. I can go with it, but I guess working out why is going to be exercise 9. The other thing about modulo n is you're trying to identify numbers which have the same remainder when dividing by n. Yes, so if you have like x mod 3 equals 1, it's always going to be some multiple of 3 plus 1. So like, or there's like infinitely many solutions, I guess. First, I like to introduce isosceles homomorphism that way. Oh yeah, it's like, I thought those were a pretty central idea to algebra, and those are, like, they are pretty late in the book, aren't they? I'm on page 30 right now. It's like, where are they? Because I can't tell you what an isomorph... 120 pages of them? I mean, I guess I don't really know. You do all this stuff with groups. Then you get into isomorphisms. I guess I don't know if algebra to really comment, but... Alright, so there's a lot of stuff. There's Silo. His name is Oslo? It's pretty cool. It's like if my name was Washington, D.C., my first name. Okay, back to page 30, though. Oslo's probably a cooler name than Washington, D.C., though. So it's an example of why you would use the, modulus. Kaylee's saying, how you obtain a beautiful theorem without difficulties via group actions. Really? Okay. Something to look forward to. Okay, so this is the ID number in the last digit is the modulus. They take it mod 9 arbitrarily. Okay. Oh, you know, I remember I don't remember if it was like modulus, but Brian was talking about like an accounting trick that involved like switching digits around, and it involved like multiples of 9 in some way. So 9 might actually be an intentional choice rather than an arbitrary one. Maybe this is the same, I think. So yeah, they're talking about the same thing with like switching digits and all that. And is a nice modulo to use. 7 is just rude. I'm trying to get the joke. Isn't that also true for 7? Oh, wait, oh, never mind. Oh, I thought you were gonna make a pun. Okay, okay. 9 is a shortcut. Sorry, I thought that was like I, okay. Never mind. Dot product notation for 2 k tuples. So you have a string of numbers dotted with another string of numbers. Are we doing single digits for each of these? That seems like the implication to me. I don't know if it's generally true though. Okay, yeah, single digits, I guess. Well, you could define it to be for many digits, but in this case with UPC, at least it's single digit. Sorry, someone's driving by slow, like blaring their music. I think my mic is picking up a little bit too. So wait, you just... Huh. You dot it with just 3 1 3 1 3 1 3 1. Then you mod it with 10, and that's your new check digit? That's called the weighting vector. Okay, I was about to ask like what the name of that is. I don't think if it's like application part is really... I mean, I guess it probably is important because they're introducing some stuff. Oh my god, please stop playing music. Mid and foot jumps into iso/homomorphism pretty early on. Oh, okay. I don't know enough about algebra to say like what's proper or what's not, but I'm just kind of going with it because this is the book that was chosen for Penn Center's group. Okay, do we need to go like this deep into UPCs? I mean, this one might be helpful to see. Okay, so we add on 2 more digits and define them to be whatever they have to be, such that when you mod it with 11, you get 0. And I assume 11 is chosen so that this is possible. And if you dot it with the weights 1, 2, 3 up to 10 mod 11, you still get 0. Okay. Just going with that. Now you have 2 equations and 2 unknowns, although I don't know that you break those out. What? You're using mod 11. So, okay, no, they haven't combined these yet. They subtracted 11 from all of the coefficients here. Okay. Did they explain that earlier on? I can just go with it. I don't think they really say it explicitly. But okay, let's just believe that. Add this to equation 1 prime to get positive 7 minus a9. The a tends to go away. What happens to the mod 11? We have to drop mod 11. But yeah, so I think I know that underscore. They're taking this and they're adding it to that. And I'm curious why the mod 11 gets dropped entirely in the result down here. Just plow through it. I might need to look up modular arithmetic separately at some point, because like, these rules are so weird. Because A9 has to be a digit? I don't see how that makes you... I don't see why that lets you drop them on 11. Does someone know this must be a multiple of 11? Or... No, I don't know. Well, 1 prime is this right here. So I did 1 prime, plus this rewritten 2 prime, and obtained this 7 minus A9 equals 0. And I have no idea why. Like, I could see it being 7 minus A sub 9 mod 11 equals 0. Oh no, Anders. Okay, so it is, but the book is saying there's no mod 11 there. So was the book wrong? They're digits in a number, basically. The book is talking about like checksums. Need one value of A9 that works. You don't need all values. But if 7 minus A9 is 0, when you do 0 mod 11, you get 11, don't you? Is 0 mod 11 a 0? Really? Maybe that's why I wasn't understanding. 0 mod 11 is 0. Oh, because I was doing it backwards, maybe. Zero. Oh, okay. Thank you for that then underscore. I was flipping the mod in my head. That's why. Yeah. Okay. You totally skipped that part. Yeah, Anders, I was gonna skip this part, but it seems like they're doing some things that could be helpful to see for like modular arithmetic that I am very inexperienced in. 11 mod 0 was cursed though? How so? It looks like division by 0. But it's actually possible, right? Or no, is it? I don't know. Is it just like infinitely, or it's just like you can plug in almost anything you want? It's just 11, isn't it? I don't know. I was thinking, I guess that one would be 11, but I don't know. Mod hurts my brain because it doesn't fit the way that I normally do division. You'll see when you can divide by 0. Ooh, okay. I mean, if I study rings, so let's see if I get that far. Let's look at example 6. The sum of the cubes of any 3 consecutive integers is by 9. I feel like I've done almost the exact same problem. This is a much shorter way of doing it, though. What? You can't just say... No, you can't just put a box there. You didn't do anything, book. That's like the start of the proof. Like, you didn't actually prove anything. God damn it. Okay. It's an exercise in toiling. Yeah, I mean, this would take for forever. I've connected the 2 dots. Because, like, this is a pretty tedious problem, checking it for 0 through 8. I think the one I had, it was the sum of the first 3 squares, or first 2 squares. Mod 9 is 0, and you could do a trick where it's the same thing as doing with mod 3 or something like that. So you could simplify it in that way. One thing is division is an operation, but its concept of divisibility is a relation between integers. The definition applies something wrong and say 0 divides 0. Okay. Mercury, over on YouTube. I have a question with a particular sum. I have no idea what that second thing you said means. If you have a question, though, please feel free to ask it. Use mod 4 arithmetic to show there are no integers x and y, such that x squared minus y squared is 1002. Really? That's random. Okay, say take the mod 4 of each side, so x squared minus y squared mod 4 is 2. Okay with that. If n mod 4 in Mercury, what about vectors, I guess? Then n, wait, if n mod 4 is 0 or 2, then n squared mod 4 is 0. That's because if n divides 4, it must have a 2 inside of it. So if you square that number, it now has at least 2 2's inside of it, which means that the mod 4 would be 0. Okay? Anyway, send me a picture of the question. If you're willing to join my Discord, you can post a screenshot. The rules of arithmetic and Reed's proof was that once you've studied 9 consecutive cases of n, you'll loop back to the cases. Oh yeah, I understand that underscore, that you could, you know, with like a mod like that, there's no point in checking anything beyond 0 through 8. It's just doing the actual check, I feel like is the real proof. And this is like the idea of it, but like, I feel like that's kind of lazy. I don't know. I should name my firstborn... I don't know how you pronounce that. What is... I see Nas in there, which makes me think of like Lil Nas X. Does that have anything to do, like... Or like... Did someone actually do that, Viv? And Mercury, you can put the question in math homework help or math discussion. San Francisco 49ers? Oh, okay. I get it. Mod 4 is 1 or 3. Then n squared mod 4 is 1. That one's a little bit harder to understand. M Hall, thank you for the follow. And Mercury, keep an eye on my Discord for when you post it, or let me know if you can't find the spot, and I'll make a thread and at you in it. Yeah, I haven't seen the recent seasons of It's Always Sunny, but I forget what number season I've gone up to, but I really like that show. I'm pretty behind on the recent seasons, though, unfortunately. If n mod 4 is 1 or 3, I don't know why the extra mod 4 is right there. You love it so much? Yeah, it's so funny. Oh, I bet maybe if you if n mod 4 is, you would write it as like 1 more than a multiple of 4, square it. You would get what, 16, like, you know, k squared plus 8k plus 1, which is 1 more than a multiple of 4 still. Okay. And then if you have 3 more than a multiple of 4, you do the same thing, but instead you get 16k squared plus 24k plus 9, which is only 1 more than a multiple of 4. Okay. I'm on board with this statement then now. Dennis gives the Charlie speech. I don't remember what the Charlie speech is. Honestly, one of the things that gives me the most is whenever Charlie sings. Like, that actor is so good at singing, but like the songs that he makes, like are also like super funny. The only differences of the squares of integers modulo 4 are 0, 1, and -1 equals 3? Yeah, he is. All right, let's see what this clip is. I never passed up a good chance to look at it. It's Always Sunny clip. Oh, this one? I think I remember it now. Oh my god, yeah. This one is so good. Dennis is running for office and Charlie wrote the script. Oh my god. Yeah, I know. Charlie's so into it. Yeah. So do. Oh, did you post it? Uh, oh. Okay. Mercury, I'll make a thread for you. Uh, uh, all right. I made a thread for you if you're the, I hope that's you just joined at least. In the Homework channel? Oh, can you try posting the thread that I made? Okay, cool. You did. Oh gosh, what's happening here? Okay. Let's see what we're working with. Diagram is not accurately drawn. OA is 4A. OB is 3B. P is the point on OA such that... Now, when they say accurately drawn, do they mean to scale or that they actually messed up some of the points here too? Because that'd be kind of evil, but I assume that the points are in the right spot. That'd be a little too evil. P is the point on OA such that OP to OA is 1 to 2. Okay, so that part definitely is not accurate. I see. So yeah, it's just not to scale. Q is the point on AB such that AQ to... Oh wait, no, that is accurate. They're saying this is the midpoint. AQ to AB is 2 to 5. So this is... How do I do that ratio in my head? 2 times AQ is 5 times AB. No, I have that backwards. 5 AQ is 2 times AB. Okay. Find simplified expressions in terms of A and B for PB. Oh, God. So for vector PB, also it's terrible. So I need to remember how vector addition works again. Like geometrically. A and B, A plus B, okay. That's what for some reason I thought you connected the endpoints, but you don't. So from P to B, and we need to express that with vector addition, is my assumption, in terms of OA. OP or OA or OA and OB ultimately. OA and OB. Do. So do PA plus AB. Is it? I assume A and B are also vectors. It's weird to have the notation mixed, but I've seen a lot of books they'll use bold to mean a vector. But usually they use either the arrow or the bold and not both at the same time. So wait. So Mercury, you're saying that PB is PA plus AB. Oh, maybe. And that's what underscore is saying too. Yeah, Yanis, unfortunately. At least it's vectors though. I feel like these are a bit, they tend to be a bit nicer. PA plus AB. Oh, I think I see. Okay, yeah. You have to if you translate AB over to start over here, then the sum of those is PB. Okay, I think I'm on board with that, Mercury. So actually, are you asking about a certain part? Because I'm still trying to wrap my head around the what's even happening here, but yeah, I guess for one I agree. We want to do PA plus PB, or sorry, PA plus AB, but you still have to work it out what is in terms of OA and OB. You're asking about part D in particular? All right, maybe we should just skip there. Find the area of the triangle, oh gosh. OPX, we want its area. The area of triangle AXQ is 10. So wait, we want OPX. I think I need to zoom out a bit. There we go. So OPX is what we want. OPX. We know AXQ is 10. Okay. Isn't there a relationship between vectors in the area of a triangle? I think it's going to rely on some stuff from earlier parts of the problem. Oh, okay. Underscore. Oh, you do 1/2 of the cross product. Okay. Well, cross product, that is the okay, yeah. For two-dimensional vectors, you can do a cross product still. But another care about is the magnitude. Okay. Uh, there's a person asking about part D. from this. That only applies for 3D? Oh. I mean, 2D vectors also in 3D is my wishful thinking. Immerse them in 3D space. Okay, yeah. 2 and 3 component 0. Okay. But I don't know if that, I mean, so if we want from the area of triangle OPX, we're given, are we given any other hard, like, values here? I guess that's a good question. So, Mercury, do you know what the cross product is of 2 vectors? Because if not, I assume we're just going to be reduced to some kind of geometry puzzle. We do have some proportions between sides, like OX is some scalar of OQ. Part D, find the area of triangle OPX. So Mercury, do you know what a cross product is of 2 vectors? All right, bye, Yanis. Thanks for hanging out. Oh gosh. You don't? Okay. So no cross product allowed. Hey, Caden. If you have a question, feel free to let me know. We're going to do this one I have up first, but you would be next. Or if you want, just like put the question right there, and if it's quick, I can just try and like get it done with. AXQ, man. So what are we? It's a contest problem? Oh, I'm not good at contest math. I'm gonna honest, I probably can't do it. Unless it's someone like real, like basic, I guess. An expression for AX. I'm trying to see what parts of the previous questions are going to be related to D. This might just be a little bit too hard for me, though. You can type them there in chat, or you can put them in my Discord. You know, from your friends. Yeah, sorry, like maybe I could get to the bottom of this, but I think I need to work through all of these for myself just so I understand them, like A, B, and C. And then it's going to still take me a lot of work to figure out what D is, and I think it's going to be a bit too much for me. So I'm sorry I couldn't really help you out, but yeah, this one, it does not look easy, so thanks for trying, at least. If you have anything that's like a bit more like a not at the end of a four-part question. I guess that's more like self-contained. I'm happy to take a better like look at it. And Caden, if you want, you can post your question in the math homework help like forum. If you can't find it, just let me know and I'll put a thread in there and ping you in it. All right, so while I wait to see Caden's question, I'll just kind of briefly go back to looking at the abstract algebra stuff, I guess. And if you pose the question, Caden, and I don't see it, please just type something in chat. So, oh yeah, I was working on this thing here. So I just felt like I understood this statement here. You know how to send in Discord? Is that you who just joined it? Mercury, I'm normally live Tuesday, Thursday, and Saturday, starting 3.5 hours ago, whatever that is in your time zone. If you're willing to go over to Twitch, there are more math streamers out there than just me, but I'm not aware of any on YouTube. Caden, you sent it. Oh, more geometry. Oh gosh. Okay. Let's see if we can do it. This is a competition geometry question, so I'm not the most optimistic. The vertices for polygon QRST be 0, 0, 0, 16, 9, 16, 9, 0. It's coordinate geometry, I guess, which I've never like officially learned. Is this a square? No, it's a rectangle. Seems like it. Can I just confirm the answers for A and B, which are 36 and 8? I don't know. A is 36, B is 8, is what you're thinking? I guess we're gonna have to draw this for ourselves. So let's try that. Twitch username is the same. It's like I'm chatting from this Donda's Math and Gaming account because the YouTube thing is kind of stupid. But that's my Twitch link there. I don't know if that's gonna be that readable on stream, but I'll just try putting it like that. Need your help to explain it? Or need your help to explain C? Okay. So let's work through A and B first, I guess, so that way I understand what's happening here. But if it's too hard, I might not be able to do it because it's geometry is just really hard, and it's competition geometry. There's going to be a good chance that I can't, to be honest. Caden, thanks for the follow on Twitch as well. Thank you. All right. Well, I appreciate it. So we have 0, 0. I'm gonna make things go by twos, I guess. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. Okay, 0, 0. Wait. Oh wait, I had that backwards. Ugh. It was 0, 16, not 16, 0. 4, 6, 8. 12, 14, 16. So we have a rectangle. Any other guys doing math live sessions on Twitch? Yeah, those are people that I linked just before Mercury. All right, see ya, Anders. Thanks so much for hanging out. Why is YouTube more delayed than Twitch? I don't know. I'll link them in both Twitch and YouTube, but those are people who I can recommend. So I highly recommend you just like go down that list, open up their links and hit follow. So question A. M is the point of intersections between the diagonals, okay? So that's M there. We want the area of SMT. SMT. So base is 16. Height. Okay, well, the entire diagonal of the rectangle is what? Square root 9 squared plus 16 squared. Um, 256. Is that a perfect square? Oh, that's 3, 4, 5. That's a 3, 4, 5 triangle, isn't it? No. I don't know. It's not 3, 4, 5. Oh, you're right. It is half. Yeah, let's not worry about the length of diagonals. Sorry, I was trying to work out the distance between M and that line there. But we don't actually need that. Or I was trying to work out the hypotenuse, I guess. But you're right. We have, yeah, okay, never mind. We know the distance from M over there is basically half of the entire length, which is 4.5. We know this is half the vertical length, which is 8. So to 2, who cares? Well, yeah, so we'll do 2 times the area of that smaller triangle. I'm not going to bother like making a thing. 2 times 1/2 times 4.5 times 8, right? 4.5 times 8, 36. So I agree with your answer for part A is 36. Caden? Part B, there's a point A0 such that the ratio of the area, incorrect? Oh, you are correct. Okay, never mind. I was like, oh gosh, don't tell me I'm incorrect. Although please do tell me if I'm incorrect. Yeah. I missed a space there and the M looked like N. Yeah. Okay, cool. So part B. There's a point A, which is A0, such that the ratio of the trapezoid AQRS to the area of STA is 2. Okay, now it's getting a little more complicated. A Friar contest? I don't know what that is. I hope that's a joke, though. Waterloo? Oh, okay. Point A. It's actually called Friar? Oh, okay. So there's a point on the x-axis somewhere. How should I draw this? No, I'm not. I'm not a professor. I have a bachelor's in applied math, and I've been a tutor in a tutoring center. So I call myself a tutor, not a professor. AQRS. Okay. Oh. So you're taking a point A right there. That makes this twice the area of that. Okay. Well, the area of a trapezoid, that's like A plus B over 2 times height. So the top is 8. The bottom is just A, because we're going from 0 to A over 2. The height is 16. Okay. The area of the triangle AST, right? Or STA, same thing. Just match what the problem says, though. It's 1/2 base times height. So 1/2, the base is 8 minus A. The height is 16. Really? Oh. I guess that's what we get. And then this is twice of that. So we set up the equation 64 plus 8A equals twice 64 minus 8A. And solve this for A, I hope. 32 plus 4A equals 64 minus 8A. Subtract the 32 over, add the 8 over, 12A equals 32. They have 4 in common? 8 over 3? Does that make sense? It's what, 2 1/3? Oh my god. It's the length is 9. Thank you, Brownie. Thank you. I messed that one up, didn't I? I don't know why I started calling it 8. Wait. Oh yeah. 9 plus A. 9 minus A. Okay. 72 plus 8A, right? Good catch. Now we get 3, right? Did you get 3, Caden? You got 8. Really? Huh. AT is 9 minus A? Okay, yeah. So now it matches, but you get 8. Okay, yeah, let's see what the see what we did different. Yeah, 8's a little high, I feel like. You can check by plugging it in. Oh, that's true. Let's even spot the error in this work, though. Because I feel like 3 is a pretty reasonable answer. So you did 1/2 16 plus A times 16. You said this is the area of the trapezoid. Shouldn't it be 9 plus A? Because you used the height twice, didn't you? I think you misused the area of a trapezoid. And then 72. I don't know why it's just 72 on the bottom either. The area of the triangle is definitely 72 minus 8A. See, this formula doesn't seem quite right, Caden. But if you know what I did, then I think you have the right idea. Yeah, so I mean, are you okay with B though so far? Or like, you know, with what I did for B? Okay. So yeah, so now let's look at C then. Through B, which is 0B, C, which is 3, 4. Oh gosh. My God, this is such an escalation. I need to draw this. I don't understand the question is asking yet. Where am I gonna put this? Down there. Yeah, that's fair. Brownie. Okay. So start with C, because we get hard numbers for that. 3, 4. D is actually fixed for A given B. I don't understand what that is yet. The line passing through B, which is 0, B. So B is, no, sorry, B is somewhere over there. D is somewhere over here. I guess you're given 3 points for a line. You can always determine the third one. Is that what you're saying? Yeah, okay. Like, you don't have that much freedom in choosing your B and D. They have to line up through 3, 4. B and D are positive integers. Determine all possible pairs of points, B and D, which the ratio of these two trapezoids is 11 to 5. Yo, hoo, how's it going? So I assume there's only going to be 2 possible answers. There might be more. That might be dangerous to say, but I feel like, you know, you'll get like one answer and then you can like reflect it and that'll be your other answer. Maybe there's more than 2. But that's kind of like my first instinct. I'm good too. Just working on this geometry problem, which is not easy. But we might be able to work this out somehow. So let's just pretend, like, what kind of form would we expect for B and D? Like, would we expect B to be down low? I think, or, yeah, I feel like B being up high just kind of closes off all your possibilities here, right? So B is probably low. So maybe we don't have a reflection. You know, so let's just like kind of arbitrarily draw a line just so we can have something to visualize here. That's gonna be up to, like, I feel like there might be only one solution after actually looking at that. Thank you for the luck, hoo-hoo. I'm definitely gonna need it. So yeah, I mean, start by expressing, yeah, because that's the y-intercept of the line, so B is a lot easier to work with, I guess. So so the slope between these 2 points is you rise, well, an arbitrary amount, 4 minus B over, and you run you're always running 3. Plus b, your y-intercept. Okay. Now if you plug in 9 for x, y is d. So d is 12 minus 2b. It's a competition problem, Stooky. It might be possible for me to do this, though. This is from Caden in chat. Got a couple regional first places and never did well at state. Oh, funny. I never even touched any type of possible competition math. Okay, so now we can like potentially ignore D and only work with B's. So now we want to express the area of the trapezoid above and below and apply our ratio. Hey, Sergeant Duck. So the area of, let's say, BDTQ is going to be D plus B, which we know what D is, over 2, times the height of 9. Now let's plug in what we know about D, which is 12 minus 2b plus b over 2 times 9. Keep simplifying that. It's 9 times 12. It's 90 plus 18 is 108. Okay. And then the area of BDSR, I guess, is 16 minus b plus 16 minus d over 2 times the same height of 9. So many really named contests. Hey, Park Jammer, is this an eigenvector-friendly space? I'm not very good with linear algebra, but eigenvectors I kind of know. Welcome in, though. So we know what D is, and we know 16 plus 16 is 32. Minus B minus 12 minus 2b over 2 times 9. 32 minus 12 is 20. Minus b plus 2b is plus b over 2 times 9. Getting in the way of the cat now. 180 plus 9b over 2. Okay. Now we use the ratio. What the heck? It's minus and plus again. Is there some fact that I'm missing? Yeah, there's probably some fact that I'm missing, but that's okay. I guess I'll definitely be making jokes that are going above my head, but okay. So we're interested in any integer solutions that 11 times 1 is 5 times the other. So we got to try both combinations. I assume we're only going to get one integer answer, though. Yeah, it is symmetric. Okay. So let's try 108 minus 9b over 2. over plus b over 2. So we'll do 11 over 5, and then we need to flip it. And then we take any integers that we find for b. So the 2's cancel. Gonna cross multiply. Actually, I didn't really cross. Oh yeah, I did. I don't know. It doesn't matter. Cross multiply is kind of like a buzz term anyway. This is annoying math. Why 11 to 5? There's probably a reason why it's 11 to 5, but all right. I'm not doing all that mentally. Let me break out Wolfram Alpha. Actually, no, I'll just break out the calculator app. What's 5 times 108? I probably could do that in my head, but I'm not going to trust myself. 540. Minus 45b. Now 11 times 108. 1188. 99b. Divide everything by 9. Does 9 go into that? Oh, it does. You're right. Too late now. No, that actually makes it so much nicer. You're right. I should do that. We'll divide 9 by each side. Because 9 times 11 is 99. So that's 9 times 12. Didn't I do 9 times 12 at some point? I don't know. Okay. See, I divided each of those by 9. Using the trick? No, 1, 3, 2. That's the trick. Because it's 1, 1, 2, 2. 1 plus 2 is 3. Okay. Okay. We're going to get a negative answer here. This one is the bad one, I think. 72 is equal to 16b. Oh, wait. Yeah, it has to be between 0 and 16, right? Yeah, they have to be positive integers. So this is already out. B is negative. So let's flip the fraction and try again. Actually, rather than flipping the fraction, I'm just going to reverse the 5 and the 11 there. Actually, the 5 and 11 here. Let's try this. $60 plus 5b. Oh, am I getting cut off by the problem? I'm about to be. Okay. Keep that in mind. So I can't see the problem. It's like right there. So I sometimes forget to not write underneath it. 72 is equal to 16b. Please tell me that 16 goes into 72. 32 plus 32 is 64. No, it doesn't. What did I do wrong? Wait, I don't know if you guys knew this, but 180 and 108 are different numbers. That's a really important fact that I, picked up at some point during my degree. All right. Isn't that weird though? Shouldn't they be the same? Maybe they just aren't. I don't know. Let's just go with the numbers that I got here. The actual numbers that I got, not the rearranged versions that I made up. And it's actually going to be easier if I write it as like 9 times 12 minus b over 2. And that one's times 20 is b over 2. Okay. So the 9s and the 2s will cancel out. So I'm just going to write 12 minus b over 20 plus b. Okay, try solving that for b. $60 minus 5b is 220. Okay, that's a negative answer. So let's try the flipped version. So we don't want bs to be a positive integer. Uh, 132 minus 11b equals 100 plus 5b. 32 is equal to 16b. b equals 2? Could it be that b is 2? Okay. Well, let's not celebrate too early though. Let's actually check our work here. You think b is 2? Okay. If b is 2, then d is 8, right? So 2 plus 8 over 9. Or 2 plus 8 over 2 times 9 is 45? Actually, I nearly drew b at 2 anyway. That's kind of funny. So now the upper trapezoid, it's going to be 16 minus 2 is 14, plus 16 minus 8 is 8 over 2 times height 9. 22 over 2 is 11. 9 times 9 is 99. Let's see if those are in ratio. Oh, wait. Can't we just do 99 over 15? Or 45? Is 11 over 5? Because you divided me by 9? Bam! I actually did a problem. Okay. Oh my god. Frickin' geometry, man. So yeah, Kaden, I guess let me know if you have a question, because when I don't understand where a problem is going, I explain it even more poorly than usual. So if you want to back up, I'm more than happy to. But if you understood, yes. I'll take the face cam off. You got it? All right, sounds good. Well, thank you for the question, I guess. You know, I'm going to refund Andrew's points from way earlier. Okay. God, what a question. Way before. I think underscore said something was related to the example 7 here from the abstract algebra book. If you're still here, underscore, I'm happy to hear it, but if you did leave, I completely understand. You also wouldn't hear me if you had left, but... where even was I in this, number 7? I just understood, oops, like this part of it. What is this saying? What if the squares of integers modulo 4? Caden, I'm normally live. So I do math streams and gaming streams. On YouTube, I only do math, but on Twitch, I do gaming and math. So my math days are Tuesday, Thursday, and Saturday, starting 4 hours ago, whatever that is in your time zone. For me, it's 1 in the afternoon Pacific time. I think I'd linked them to you before, but just I can't shout them out enough. If you do need math help and I'm not live, there's many other math streamers out there on Twitch, including Ian Stuckey. He's in chat here. Actually, oh, I need to update that command. Bob isn't really active, but also, yeah, it's fine. Everyone in that chat streams math. Nope, Rob isn't like super active now, but everyone else in that list. There's pretty much someone who will be streaming math every day of the week, I think. Yeah. It may not be at the perfect time for you, but at least 1 day a week, there should be someone who's streaming math, so out of that list. I also have a schedule uploaded to Twitch that should localize it to your time zone as well. It's if you're on like desktop, it's right below the stream. It's like a scheduled tab, I think. If you're on mobile, then I don't know. I have no idea what the sentence is saying. The difference is of squares of integers modulo 4. Like, what order is this all happening in? Well, I guess it's like basically making this statement. I guess like, when are you squaring, when are you modding each number, and all of that. With modular arithmetic, it might not matter, I guess, but I think that's they're saying in words, this part here. Like, I'm trying to translate these words into actual like math, but I think that's just the math translation right there. But then I don't get this part. Like, zero, 1, and -1 equals 3? It's supposed to be a contradiction. I know that, but I don't know what... How, like... How do you have -1 as a result for a mod? I guess that's the part that I'm stuck on. The 0 and the 1, I see how we showed that earlier in this argument here and here. They mean -1 mod 4 is 3? Okay. I think. I'm saying like there's supposed to be something that doesn't make sense here, but I don't know why it doesn't make sense, or I don't know what's trying to say in the first place, much less why it doesn't make sense. Set of all numbers modulo 4 cannot be 2? A squared and b squared are either 0 or 1? I'm kind of confused because if we've shown that there is some kind of scenario where the mod 4 gives you 0, aren't you proving this, not disproving this? Well, I guess we assume that there are two integers. Well, the difference mod 4 was 2. In mod 2 integers, you can only get 0, 1, or 3. Where do they say that the difference should be mod 2? Oh, literally when they say there's an integer solution such that mod 4 equals 2. Oh. Okay, and so 0 and 1 are covered by, like, pretty directly by the casework that we did up there. The -1 is if you have x and y reversed and y squared is greater than x squared. Okay. But then okay, so then when is it equal to 3? What does equal to 3 even mean part? Like, why aren't we just done after we say the only difference in squares modulo 4 are 0, 1, and -1. None of those numbers are 2. Are they saying there's 3 things that it could be, and we expect to only get one thing? You check that -1 isn't 2? Well, yeah. So I I So they do all the work up here to show it for, when the mod is 0 and when the mod is 1, but then they just kind of say that the mod of -1 is 3. I assume it's the same kind of argument as the one they made here. But you happen to get 3 instead. Okay, so let me, I guess, in this part of the proof, they're checking all the possibilities for n mod 4 and what those imply for n squared mod 4. If n is even, basically, if n mod 4 is 0 or 2, then n squared mod 4 is 0. That makes sense to me. And then if n is basically odd, so n mod 4 is 1 or 3, n squared, it must be that n squared mod 4 is 1, which I'm on board with. I worked that out, at least in my head. I'm confused. I think this -1, they're doing that same argument as up here, but they're kind of glazing over it, and this is accounting for a case where maybe y squared is greater than x squared, but it's going to be basically the same argument as what happened over here, but for, we happen to get 3 instead of 1, and either way, neither of those are 2. That's my interpretation of what's happening. Accurate? Okay. Then I think I understand this. I feel like I should look up like a worksheet of just like numbers mod numbers and practice breaking them down into the like qn plus r form, or whatever, like this. Because I get kind of confused when there's negative numbers involved, or like if the result is less than 1 if it was normal division. Good news for me? What's that? Because like the cases for mod up here are really easy for me to like do in my head, just knowing what mod comes out to be, but these cases I get tripped up on all the time. It's only number 3. Oh, were they the practice problems that Penn was saying? Let me see. Is that a bean? Okay, anyway. Brownie Man, thanks for the follow. GCD, LCM. Oh, I mean, this is probably going to be helpful for me to do. Let's just do that now, right? Before I even move on. Well, the modular arithmetic, it's kind of fresh in my head. I'll go down there with that. That's still like a good few things packed into one question, though, at least. Oh no, okay, sorry, Cat. You now lack an ear and half of one of your eyes. Also half of your back. Okay. So what's up first? We have 51 mod 13. I mean, that's going to be 12 off the top of my head, I think, right? But I want to actually show it. 51 mod 13. Okay. Is this, that's not literally equal to. Let's just, I want to practice re-expressing mods as the addition in multiplication. So 51 mod 13 implies that 51 is equal to some number times 13 plus some other number r, and the mod will be r. So if I were to do the division, oh wait, 15, dude, what? How do I do this? I made 108 into 180. I made 15 into 51. Okay, anyway. 13 times 3 is 39. So let's plug that in for n. 51 minus 39 is 12. I wrote the wrong thing again. So that's why 51 mod 13 is 12, because this process I would do in my head, but I don't really actually think about it. So I want to actually drill that like long way. Oh, the 3 lines for that? Maybe. I mean, doesn't that get into like numbers are congruent to modulo whatever? And I get confused on those. But they might have like, you know, in modular, doesn't have like a meaning, the triple bar. $342 mod 85. Now I wonder if there's a trick here where you can look at the factors of these. I mean, maybe it's not that bad to just do it the old-fashioned way too. That's what, 17 times 5? Does 17 go into that? No, it doesn't. I don't know if there's really even a trick with that, even if they did. So let's just do it the old-fashioned way. So how many 85s can we fit into 342? 85 plus 85 is 170. 170 plus 85. It's definitely going to work. 170 plus 85 is 255. 255 plus 85. Oh, is that 340 on the dot? 255 plus 85. It's 340. Because just checking work. 32. Sorry, no, you do 20, 0 to 340. Yeah. So R equals 2. Is there an easier way to get that, I wonder? $17 goes into 340. That's the trick. So you say, well, so 17 goes into 85 and 70 goes into 340. Is Is there something you can do with that to make this math easier? Because I think the later problems are going to make you like, you know, kind of make you manually do some tricks, and maybe that'll help me out. Maybe I'll just keep on doing these. And maybe there isn't a trick in that. Okay, 62 is... we want 60, right? R equals 2 again. Coincidence, I think. Don't know? Okay, that's fair, Brownie. Yeah, you don't have to have all the answers. I'm just kind of like... I'm so unfamiliar with like tricks for, or like how like modern arithmetic actually works. That's why I'm doing this exact thing here. So we get R equals 10. So it's a case like this where where the usual trick was just figuring out how many 15s fit into 62. I guess it does work. I have to modify my thinking a bit. Like I'm not expecting to get 0 for an answer. $82 times 73 mod 7. Here we want to do, so it seems like the book was saying you can do 82 mod 7, mod 7, times 73 mod 7, and then take the mod 7 of that thing. So 77 gives you a remainder of 5. That gets you a remainder of 3. 15 mod 7 is 1. Let's check that. Just gonna plug it into Wolfram Alpha quick. One. Okay, good. Now we have what? 51 plus 68 mod 7. I think you do the same thing as with this, but now you have a plus. $51 mod 7, 49 2. 68 mod 7 is 5? Because it's 2 below 70? Which means it's, yeah, 5 above 63. Mod 7. And then 7 mod 7 is 0. 51 plus 68, that's 119. 7 goes into 119? No way. You get, wait, 119, 49. Oh, it does. Gosh darn it. Okay. $35 times 24 mod 11. Okay. So the same trick is up there, I guess. 35 mod 11 is 2. 24 mod 11 is also 2. Oh, now we get a case that's like up there, which maybe now I feel comfortable. Well, no. I don't feel comfortable enough to not do that thing. So that implies, because the 10 goes first, I always get tripped up with that. It's like the smaller number goes first now. That's why it's 4. Okay. 119-year-old nemesis. Yeah, false prime. Oh yeah, you were you talked about that on the podcast, right? Or 57 is your favorite prime. I remember that. Because it's not prime. 47 plus 68 mod 11. $119 by name. Oh, that's right. Yeah. Three. 2. Mod 11 is easy. Nice with 2 digits. It's gonna be 5 mod 11, which is 5. Okay. And that's all of them for number 3. Okay. Oh, yes. Actually, yeah, they don't give any negatives. You're right. I should absolutely try that one, Suki. He can't keep getting away with this. He said negative 62 mod 15. Yeah, let's try that. I was taking that one. That implies negative 62 is equal to some number times 15 plus r. Some number, I guess, is negative 4. I was ahead of myself, it seems. 62. R is negative 2? R is positive? Does it? Even? It should, so I have to go over? Do I want negative 5? See, okay, I'm really glad you asked this, because not. Let me scroll up. See how they broke it out. They don't say that it necessarily has to be positive. I feel like R should be positive or 0. This is, I need to Wolfram Alpha this because their example doesn't really, Oh wait, R does have to be greater than or equal to 0. Really? I don't see them saying that, but it makes sense to me if it does. That is one choice which guarantees uniqueness. Okay. So then we want to theorem point 1 a few pages early. Oh, okay, okay. So we need to go over now. So we want -5, which gives us -75, which gives us 13? That's weird. I don't like that. But I can remember that. Because it's modular arithmetic, I guess. So really, -62 mod 15. It's 13. Okay. Oh, that's where they say R is non-negative. Okay. Fair enough. I just have the memory of a goldfish. It's not my fault. Yeah, so honestly I did not know that this is even slightly related to abstract algebra. I thought it was just like groups. I thought it was like too abstract to even care about modulus, I guess. Okay. Isn't just discrete math? Well, you're in luck, because example 7 was just where I was just on. I want to look at example 8, and then we get to do complex numbers, which I'm much more excited for than modular arithmetic. Majority, I'm not familiar with that logic gate. 3 inputs and outputs 1, if and only if at least 2 inputs are 1. Oh, it's like an and, but with voting. Oh, modulo 2 arithmetic. I get it, so that's why this would work. Can this potentially be 2? Why would you need to add in x times y? That makes no sense. Wait, oh, x, what? Oh, you take the entire thing mod 2, I guess, at the end. Okay. I feel like I need to do some example cases. So I think x and y are any integers mod 2. Or x and y are any integers, and you take the mod 2 of whatever they have here. Do it have to be 0 or 1? Or maybe they work either way. I feel like they're saying using 0 and 1. Isn't 0 and 1 already? Are they saying 0 and 1 in modulo 2 arithmetic are separate? Or it's 0 and 1, but also mod 2? Yeah, I think it's kind of saying the same thing, I guess. If you only have, like, I think maybe it's not important. No. Ugh. Let's pretend x and y are only 1 or 0. If either of them are 0, or if they're both 0, the entire thing is 0 mod 2. If they're both 1, then the entire thing is 1 mod 2. So that matches with my expectations for and. Or if they're all zeros, then 0 mod 2 is 0. If y is 1 and x is 0, we get 1 mod 0, which is 1. If they're both 1, you get 1 plus 1 plus 1 mod 2 is still 1, which is good. And then when you chop off the plus xy for XOR, then it becomes 2 mod 2, which is 0. Okay. So I think they are saying 0 and 1 and mod 2 simultaneously. Well, maybe it could work for, you know, just mod 2 and not necessarily just 0 and 1. Okay. The 3 equals 1 statement kind of disturbs me, but I know what you mean, Brownie. All right, let's just get into complex numbers. This is terrible. Complex numbers, I feel like I already have some decent background in, at least. Not really good background, but like way more than modular arithmetic. What's that? It's a gag on the title, no read. Oh, okay. Is this... It's a gag on the title, no read. When is one thing equal to some other thing? Oh, okay, yeah. From like that title. Ugh. Freaking math, man. Thailanders, thanks for the follow. Okay, so they introduce it with trig form first, rather than exponential form. Or polar form. Okay, yeah, fair enough. Properties of complex numbers, closure under addition. You add two complex numbers together, you always get a complex number back. Closure under multiplication. You multiply two complex numbers, you always get a complex number back. Under division, which you have to conjugate for, it's complex back. And there's conjugate there. Oh. I never even thought of an inverse complex number, but I guess that makes sense. Demovs, right? Or no, I don't know. I don't remember. That's just a power complex. It might be Demovs. I don't know. Demov might be like taking roots, which is related to this, but. Or wait, we have nth roots here. Okay. The thing you said, the Demovs, yeah. I think it's not calling it by that name, but I think that's Demovs number 6. Oh, it doesn't really matter. Turning someone that thing came up, yeah. Oh, and that's all we get on complex numbers. All right, well, we're back to, I mean, I feel kind of comfortable-ish with induction. Back to discrete math. Yep, that was a nice little break from non-discrete math. Hey there, Oatmeal. Here the lean video on it, on what it means to be equal, and because some advanced stuff right on the prerequisites understand, just sharing it's the related thing. Oh yeah. Yeah, I think like that's Stuki linked is like I don't know. I'm sorry. I'm starting to lose words. I've been streaming for too long, but yeah, I'm sure the idea of equality is much deeper than most of us realize, including myself. This proof is left as an exercise. Classic book. Let S be a set of integers containing A. Suppose S is the property that whenever some integer n greater than or equal to A belongs to S, integer n plus 1 belongs to S, and S contains every integer greater than or equal to A. I can get on the surface how this is induction. I'm trying to kind of explicitly connect the dots in my head. So in this, A is basically your base case. And if you can prove that, or, I mean, I'm trying to phrase it in a way that just isn't conducive to how it's phrased here, but this is more or less your assumption. And then this is like the proof part for the n plus 1 part. Okay. Oh, hey, demoivres. I'm trying to. This is such a weird application of induction. It's not the kind of application that I'm used to. Construct a line segment of length root n for every positive integer n. The case where n equals 1 is given. I guess because the root of 1 is equal to 1. Okay. Now we can construct a line segment of length root n. Then use the straight edge and compass to construct a right triangle with height 1 and base root n. The hypotenuse of the triangle has length root n plus 1. Oh, okay, I guess I see how the Pythagorean theorem works there. Huh. Okay, that's fair enough. He's induction for demoivres. Ooh. Oh, and then it becomes trig identities. Okay. Strong form of induction. Suppose S has a property that n belongs to S whenever every integer less than n and greater than or equal to a belongs to S. So your assumption is now it works for a, but also between a and n, not including n. Okay. SP7 integers greater than 1 that are primes or products of primes. Clearly 2 belongs to S. Now we assume that for some integer n, S contains all integers k for 2 is less than or equal to k is less than n. Okay, so that's like the strong part. We must show that n belongs to S. If n is a prime, then n belongs to S by definition. If n is not a prime, then n can be written in the form AB. Wait, I'm going too fast for my brain now. We must show that n belongs to S. If n is a prime, then n belongs to S by definition. Fair enough. If n is not a prime, then n can be written in the form AB. 1 is less than a is less than n, and 1 is less than b is less than n, right? Because it's not prime, so you don't need to do or equal to. So you're assuming both a and b belong to S, right? And each of them is a prime or a product of primes. Thus n is... What? That's a proof? Oh, it's a prime or a product of primes, thus n is also a product of primes. Okay. Because n is AB. Okay. And I was getting a little tripped up because, like, when I say product of primes, at first I was imagining only the product of 2 primes, but that certainly doesn't cover every possible number, so it's just an arbitrary number of primes. Trying to guess, actually, how much longer do we... Oh, equivalence relations? Ooh. Okay, that's... But it's, like, I don't think I'm going to be able to stream for a ton longer because my brain is kind of pooping out here. So I'm trying to get a sense of how much more there is, to, at least to this section. Oh, it's such a long problem. I'm not reading that. Oh, and actually that brings us to equivalence relations. I think I can barely talk and I can only like barely do math now. So maybe let's try to wrap things up. Any friends going? Oh. Ooh, ooh, ooh. Penn Center is doing crowd control. Legend of Zelda. And I think we should check that out because it was fun to watch the first session. So yeah, that's gonna be the stream for the day. Thanks so much to everyone who's been here. I'm gonna wrap up the oh yeah, the YouTube stream is just gonna get cut off. If you're here on YouTube, I appreciate you. I'll be back on YouTube on